So guys, we are going to see method of separation, and this topic will be the last topic for PDE. Only this much you have to do for the PDE and go for the exam, GATE Aerospace exam. Method of separation of variables, you are already aware when we discussed this pattern in ODE. What do? We take x one side, y one side, and then we integrate separately x side and y side, and then reach to the solution. So here some similar thing we'll do. We'll take the variables one side, x one side, y one side. Before going into lecture, you understand, in PDE, sometimes what is happening, we are considering u as the variable, which is dependent variable, as the function of x and y, and sometimes we are considering z as the variable, dependent variable, as the function of x and y. In GATE exam, question can be framed on u also, question can be framed on z also. It's like dou u by dou x, or dou z by dou x, dou u by dou I, or dou z by dou I. It means they can consider u also as a dependent variable depending on x and y, and sorry, right. So let's go into this method of separation of variables. So you should know about this. This is the oldest technique for solving initial boundary value problems. Okay, IBVP. I have written here IBVP. This is not for GATE exam, simply just extra knowledge. And we can apply this method, means method of separation, only for linear and homogeneous PDEs. And what is not necessary here, that constant should be, coefficient should be constant. It is not necessary. They can be function also of x and y, but here we will not see that kind of tough level problems. Our constants will be like constant coefficients. Now boundary conditions will be linear and homogeneous. Anyway, the third point what I have written here, boundary conditions are linear and homogeneous. All these details you don't have to bother about GATE exam, just it is a part of the topic, so I gave you here. When you will learn CFD courses or any other computational courses, there you will understand that boundary condition is linear or non-linear. There you will understand more in more detail. For GATE Aerospace, directly you have to solve numericals, and I will come to that. So in this method, we will assume that our dependent variable, that can be u also, that can be z also, I have written u or z. We have to consider in the beginning itself that either u or z is the product of two different functions. One is the function of x, one is the function of y. Okay, so in this method we assume that dependent variable u or z, consider u, is the product of two functions, each of which involves only one of the independent variables. Means, so two ordinary differential equations we are going to get here. We will understand this by using this example easily. Suppose I am giving you a question, 3ux plus 2uy is equal to 0. This is a partial differential equation. Okay. What is the meaning of partial differential equation? You know very well. I told you, whenever you see any question in GATE exam, partial differential equation, you first try to solve them by direct integration, which is not possible in this case, because what is the meaning of ux? Ux means u suffix x, means you can see it is written in subscript ux. So dou u by dou x. What is the meaning of uy? Dou u by dou y. Okay. So it means your solution will come as the product of two functions. One function will be capital X, one function will be capital Y. Suppose, just an example, capital X can be e power x, capital Y can be log y, sin y, y square. Okay, I mean x will be function of x alone, y will be function of y alone. Okay, functions can be anything. Function can be anything. Capital X has to be the function of x alone. Capital Y has to be the function of y alone. Sorry. So the small u what I have written here, that small u is like a z. So finally, when the solution will come like this only, na? U is equal to function x into function y. Because from the beginning itself we are seeing that in our parent equation function will be there. We have to differentiate and we have to remove the function to reach to the partial differential equation. Here we are going opposite. So that's why we considered, okay, our general solution, our main solution, which is u is equal to something, will be the product of two functions. Okay, done. So I have written here x is the function of x, y is the function of y. Now be careful, capital X and capital Y, they are representing function directly. This capital X like sin x, log x, x square, they are the direct functions, and capital Y is again function of y. So small x, small y is different. Small x means that variable x. Capital X is not variable x. Capital X is representing a full function. Okay. Now from the above assumption, you have to find out ux value and uy value, and that value you have to substitute back in this equation, 3ux plus 2uy. So how can you find out ux and uy from that? Suppose, imagine that some side talk I'll do. Suppose you have considered function as u is equal to x square into e power y. X square became function of x, e power y became function of y. So this capital X is your x square, capital Y is your e power y. Okay. So I am telling you to differentiate u with respect to x, also with respect to y, by keeping another person constant. When you are differentiating u, dou u by dou x will come. That time y will be constant. When you are differentiating u for dou y by dou u by dou y, that time x will be constant. Correct? Okay. So from above assumption, we are going to find out ux and uy. So how will you find out ux? Dou u by dou x. That time keep y constant. So dou u by dou x into y. One big mistake I have done here. Dou u by dou x means here dou u by dou x. That is all right. There is no mistake. This y should be capital Y, because this y is the function of y what I am leaving as it is. So here you guys just correct this. Okay. This y what you see here, this is capital Y. Okay. Okay. Now from the same equation, you find out now dou u by dou y. That time capital X will be remaining and dou capital Y by dou small y. Remember, x and y, if they are small, then they are variables. Capital X and capital Y, they are functions. Don't make it complicated. Don't think that much. Simple. We have two functions. One function I am keeping constant, another function I am differentiating. Now you got ux and uy. Substitute ux and uy in your main question. Main question was 3ux plus 2uy is equal to 0. So I'm substituting whatever new values I have got for ux and uy. That is dou capital X by dou small x here into y substituted, and capital X into dou y by dou y I substituted here. So I got okay. Now what to do? From here all the steps will be completely all right. If till now you did not find any difficulty, so suppose you are not finding any difficulty in method of separation of variables, because now after this all the steps will be like very easy step. Now what will you do? From here only you have to start separating the variables. So how will you separate the variables? So right now you can see this function is only x function, correct? You can see this function is only x function, but y is included here. So I want to remove y from here. What will I do? I will divide by y, correct? So only, but here also you have that problem, na? This is your y term, but here x is also there. So it's better divide throughout by the product xy. Okay, and remember xy, these xy's are capital xy, they are functions. So x into y, that is function. So that's all. Divide. So when you will divide, what will happen? See what will happen when you divide. Here a y term will get cancelled, but x will be remaining. Here x term will be cancelled, y term will be remaining. So now you can clearly see this part is purely y, this part is purely x. So you send y part that side. So when you send y part after 0, this side, right side, then it will look like left side we have this, but right side we have this, and they both are equal. So they will be equal to certain constant, right? They both are equal. Left side and right side, they both are equal. So we can also write, okay, they're equal to certain constant k. From here a different math starts, but which is a normal trick. What is the trick? Because all the three people are equal, so you equate x term with the k, that is one thing, and then you equate y term with the k. So you can see in the line, you can see I have equated left side of the line, you see only x term with k, and right side of the line you see only y with k, correct? So then you send this dou x here, so it will become k dou x, and capital X you merge with this guy, and then in next step you, what is the meaning of dou x by x, integration for the x, and here dou x means integration for the x, correct? So this will become log x, and here this will become k by 3x, because if you integrate if you integrate 1 by x, then log x will come, and if you simply write integration dx, only x will come. So that's why here we have got log x, and here we have got only x, right? And then what will you do? Then find out this function x value. So I told you a trick. Suppose you have log a base b is equal to c, and if you find out a value alone, then this b will go for this power. It's like a is equal to b power c. So same thing here, natural log is coming because naturally you are integrating, so natural log is coming. So that's why e power, whatever is here na, everything will become e power. Done. So I got function x value. Same thing I will do right side also. How will I do right side? See, first I equated with k. First I equated with k. After that, this dou y part I sent right side. So k dou y. So you can see here, dou y by y will give me log y, and this is also function, this is also function. So here also function y will come, and minus k by 2y, correct? Because this integration dou y will give me only y, plus one constant c2. Here I got one constant c1. I didn't explain, but you understood that constant will come, c1 and c2, right? Then again find out capital Y value here. So e power something will come. Guys, remember this is capital Y. By mistake also, in if you're watching this for university exam, be careful. This is capital Y. Which one? Log y. So this is capital Y. Okay. Here you have a small y. Here you have a small x. Means what? I got capital X value also. I got capital Y value also. But they both are containing constant C1 and constant C2. No problem. Let it be. So now what was your U value? U value is the product of this capital X and this capital Y. That's all. It means what? You got the answer. You just have to multiply these answers. So I have multiplied these answers. So you can see here, when I will multiply capital X with capital Y, then this variable terms I collected together, and constant terms C1 and C2 I collected together, and I separated from the power. So it became e power C1 plus C2. This is a new constant I wrote here as a, and remaining things I wrote here. This became your final solution. Okay. So now I will summarize what we have done. See here what we have done. One question will be there, simply e as 3ux plus 2uy. This is a differential equation. We considered that, automatically we considered that solution of this equation will look like u is equal to capital X into capital Y, and also we reached to this kind of solution finally. Okay. Now our job is to separate the variable. So after assumption, what did we do? After assumption of this type of solution, from this solution itself we found ux and uy, means dou u by dou x and dou u by dou y, and we substituted back in the question. After that we separated the variable. We divided by capital X and capital Y, I mean capital XY. In every question this division may not be important, because maybe sometimes automatically the variables can be separated easily, but here we did some mathematics, like we divide. Maybe in sometimes we have to multiply something, right? So this part every student, it will depend on your own IQ, you understand or not. Okay, why are we dividing? Because we want only one variable, separate variables. And then after dividing we got separate variables, then we separated, and after that we equated to k, and then we found our capital X value and capital Y value after integration, and after that we came back into our main solution, what we assumed, x into y. So there we got, and that's all, right? So now you go for the next lecture 7, and there you understand more examples.